Today we're going to be going over how I can use tracing to connect the front end of my system to the back end and see how some of the errors are propagating out and affecting my front end experience. So I have this demo app here using the development and build of React. There is a backend server that is running Express on Node. And we have some other things like a third-party API from JSON placeholder that we're able to ping and a Supabase table. But today we're going to just see how errors are propagating out from our backend to our front end and how tracing kind of helps us paint a better picture and see what might be happening. So we have this upstream error module where we can see we're triggering some errors. We have this typical, React error where we're just throwing something in the code. But we also have this server-side error. Now, when I press this button, it's actually going to try to render this component with some information from a backend endpoint. And we can see that in the console log. Let me just go ahead and clear this. If I press this button, you'll see there is a GET request to this localhost API debug Sentry endpoint that's 500ing out, and we can see that there's an error occurred with the server error 500. Now, we do have Sentry turned on. So we're actually able to automatically capture these errors in the issue page. We can see that these were all triggered, 18 seconds, 39 seconds ago. These two we knew about. We saw them in our front end. This one is happening on the server in the back end. So in my browser, I'm not able to see that error happening. However, we know that it's happening on the back end server because we have Sentry turned on. Cool. That's something that a lot of people are aware of with Sentry. How does tracing make this better? If we have a lot of traffic on our server and I'm not able to immediately say, all right, these happened 18-ish seconds ago, I'm pretty sure that they're correlated because it's the same endpoint, so on and so forth. It would be really difficult to cut through the noise and make sure that I know this error is happening because this error is happening on the back end, right? There's no connection to it. However, we actually have tracing turned on this application. So if I go into this error and click last to make sure that we're seeing the most recent event, we can see all the things that we're used to, right? The replay showing me clicking the button and triggering the error. We can see all the things that are happening in the browser console. However, this is where things get useful. If I click on this, we can now see the full distributed trace. And we can see that this error is happening because of this error on the back end. Right? This error is happening on the server. Now, how are we able to assemble this waterfall? How do we know that this error is associated with this trace, right? This user session, this page load, right? How do we know that for sure? It's all happening in our code base and it's all happening automatically. So let's flip over to cursor here and we can go ahead and see what we're doing. Let's start in the error page itself. Right? So we're trying to fetch this endpoint, and if it fails, then we're throwing this error, right? That's all done, and we're not doing any sort of custom capturing in Sentry. We have this set error, right? That's capturing that. But this is the main thing that we're actually seeing. And in the app.tsx, which is our top-level TypeScript file in the React front end, we can see that we actually have two things here. First off, we have traces sample rate of 100%. That's cool. It would show us when we reload a page, it'll show us the fetches, but it won't show us what's actually happening on the back end. So it would say we're requesting something from this endpoint and we're getting something back. But we're not actually seeing any of the errors. We're not seeing the individual asset calls. We're not seeing if it's, that backend API is pinging a bunch of other APIs and building something up for us. All we're going to see is the time that it took and the request and the response body from that API. However, we have this other thing here called browser tracing integration. This is what makes tracing super powerful in Sentry. Now, every time that a session or trace kicks off from the front end, it automatically adds the trace ID into the header that we're then sending to the backend, so that the backend system, which also has Sentry tracing turned on, knows, hey, this is a distributed trace. All of the spans that I'm going to get from this, I'm going to go ahead and attach to that parent trace so that you can see it all together in this, beautiful waterfall here. So how does that look in the backend? It's easy. all you do is turn on trace to sample rate. I'm not doing anything custom. I don't have a single one of these functions wrapped in a start span or a start transaction. It's all done automatically. And this works not only in simple dummy apps like this, but it works beautifully in complicated apps with dynamic routes and complicated endpoints that are being, populated and returning complicated JSON information or images or whatever. All of that is automatically traced and assembled, again, in this beautiful waterfall chart right here, so that you can make use out of all of that information. There's a bunch of ways that we process and utilize tracing information to get more out of tracing itself, because it's a powerful technology, don't get me wrong, but it's also a lot, right? It's something that can take a while to get used to. It's something that can be a lot of information and noise. So with Sentry, over the next couple of weeks, we're going to see how you can utilize tracing to get more out of your application with Sentry. How you can use it to populate the insights modules, which can be helpful for finding slow queries, slow API endpoints, and things like that, as well as detecting things like N+1 queries. And that will be our next episode. So thanks for tuning in, and I will catch you in the next one.